Hello React Native developers, I hope you are well. William here, recording from beautiful Zurich, Switzerland. The incredible Cuberto agency, which has already inspired some of our demos in React Native, has posted this week on Twitter an example that they call the jelly scroll effect. And as always, you've been many asking me, can it be done in React Native? No. Actually, no one has asked that question, but I'm going to tell you anyways, because this example has caught my attention for two reasons. First, we ran a couple of Reanimated 2 experiments, but we didn't get a chance yet to look at the scroll gesture handler in Reanimated 2, and this looks like the perfect excuse to do so, so I'm quite excited for that. And the second reason is that with the scroll view, we don't get the velocity of the scroll. And here, obviously, we need the velocity to calculate the skewing of the elements. And I thought I was very curious to know how we would do this in Reanimated 2. And I thought also it could be fun to calculate in Reanimated 1 with the clock. So we're going to implement this example in 4 steps. First, we're going to attach a scroll gesture handler to a scroll view and calculate the velocity by dividing the delta in position by the delta in time. Then we are going to interpolate the skewing of the view based on the velocity. If the velocity is negative, the angle of the skewing is negative. If the velocity is positive, the angle of the skewing is positive. So depending on the direction in which we scroll, the transformation is different. And finally, we're going to implement the example with Reanimated 1. Of course, Reanimated 2 is still in alpha version and quite experimental yet. So if you want to use this example in your project today, you probably want to do it with Reanimated 1. Let's have a look. Mic drop, I ain't gotta preach. I just do what comes natural. Before we jump into the code, if you're interested to learn the fundamentals of gestures and animations in React Native, I hope that you will check out my online course at startreactnative.dev. My goal with this course is to provide you with all the tools and knowledge necessary in order to build incredible user interactions that will run at 60 FPS, even on low-end devices. And we have lessons for Reanimated 1 as well as Reanimated 2, and the Reanimated 2 is on the verge to receive a substantial update. So if you're interested to learn the fundamentals, I hope that you will check it out at startreactnative.dev. So here we have some boilerplate scroll view. You've seen it many times already. So a simple React Native scroll view. We have a view container to do the spacing, and we display the cards. So the first thing we're going to do is to attach a scroll event handler from Reanimated 2 to the scroll view. So the scroll view becomes an animated.scroll view from the one and only Reanimated. And we need to attach the onScroll event. And we need the scroll, yes, I think we saw it, scroll event throttle to be 1. So we catch it on every frame. So onScroll is use animated scroll handler. There will be this one. And so we get an event and a context. And the context we're going to use because so context in gesture handlers in Reanimated 2 are used to make your gesture stateful, so to keep state across frames. And here, since we need to calculate the delta in position and delta in time, we need to store the time and position of the last frame in the context. So we need the context. And so we know that what we need is to calculate the velocity of the scrolling. And we're going to use the scrolling to interpolate a transformation on the view. So let's calculate the velocity. So I'm going to create a value called velocity. So use shared value. Default is 0. Now let's calculate the velocity. We need the now. So we're going to use new date.getTime. So it gives us the timestamp in milliseconds. We need the y position, which we get from event. I think it's native event dot offset Or is it? Content offset. Yeah, perfect. Now we need to store in the context the time and the position. So equals y. And now to calculate the velocity, so we calculate dt, which is now minus context.time. And we calculate dy, which is y minus context.y. So the velocity is dy divided by dt. And so here we need to type our context. And so the type of our context is time, which is optional because at the first frame we didn't assign any time yet. And y also optional, which is a number. So here it's interesting because now it knows that object is possibly undefined, which is true. So we need to set default value for it. So if context.y is undefined, we can here just return 0. And then here for time, it's a bit tricky because if we... No, I guess I was trying to avoid the division by 0, but I think here if we return 0, we'll have now, which would be a huge number, but because we divide by 0, should be good, I think. So I think it's okay here to return now. If we want to try if this works, we need to attach transformation to the velocity. So this one becomes an animated view. And so we're going to create a style. So style equals use animated style. And so here I think it should complain because we are using it into an array and the size of the array might change. So that's a fair complaint. We are going to disable here, but obviously we should refactor this into a single component. And so here we can return a transform with skew x. And skew x we're going to interpolate from the velocity. So from velocity.value. So input range, let's see. I don't know what kind of velocity we get, but let's do minus 10, 10. And output range, maybe we can do 20 degrees. So that would be pi divided by 9, 0 and math pi divided by 9. And we want the same sign. So depending on the direction of the scrolling, we want also the skewing to change direction. This looks good. Let's have a look. Okay. So it does move nicely. Maybe it's not strong enough. So if we do 5, so we double basically. Yeah, I guess something in between maybe, huh? You almost, yeah, 7.5. Or maybe 10 was good, but here you can, so here it disappears And I think, and I'm not sure why actually. So let's log here the values. So I'm gonna calculate, so V. And so it looks like at some point, V is not a number, and that's why everything disappears. And so if this happens, I want to log dt and dy. So could dt be 0 even somehow? And that's why we would have like a division by 0. Let's have a look. So we move around. But of course, now we're not going to be able to reproduce the issue. Or is it because of the... Okay, I mean, I have the log here, so if this happens again, we will know why, probably. Interesting. Okay. Maybe it was because of the reload. So now I was looking at the type signature of the animated scroll handler. So let me jump into it. And I noticed a second signature with handlers. And now we have access to on begin drag, on end drag, on momentum begin, on momentum end. And as far as I know, we couldn't assign event animation nodes in Reanimated 1 on these events. So that seems to be like a new capability in Reanimated 2, which is pretty exciting. And we can use it to build a different kind of animation, a different kind of jelly scroll effect. So let's try it. Here, I'm gonna create a value called direction. So if direction is 0, the scroll view is not moving. If direction is 1, the velocity of the scroll view is positive. If direction is 0, the velocity is negative. And so here, this one becomes on scroll. And so yeah, we don't have velocity anymore. So here it's gonna be, we're gonna do direction is a math dot sign of velocity. And now we can do on and drag. The direction becomes 0. So here we can interpolate the direction. So if it's -1, 1, here we'll see. And now we can do skew. We can do a with spring. So add a spring transition to these state changes. So these 3 position. So with spring of this value. Let's have a look. This is not working. Direction. Okay, just needed some reload. So this is working. This is way too strong. So, and it does disappear, but I cannot log the value. Okay. So let me do 10 degrees here. I think it's just the hot reload actually. So here I move around. Just kind of a fun effect. No, it's not because of the hot reload. I'm not sure what's going on here. Let me try to log the values. So we do have a division by 0. So if dt equals 0, we return 0. So this should fix it. Now let's implement the example with Reanimated 1, because the truth of the matter is that most of us are still using Reanimated 1, rightfully so, because Reanimated 2 is still quite experimental. So we're going to create also a squirrel gesture handler, and in Reanimated 1, the squirrel gesture handler, we get it from redash. And I think we can call it scroll handler, and we can use scroll handler from redash. So we can pass it here as a property. So this one contains scroll, so our animation values, scroll handler, and scroll event throttle. So make sure to spread it like this and not like this. But actually, I should. So is that? Yeah, exactly. So scroll handler, we get y to calculate the velocity. We can create the velocity animation value using use value again from redash. And now we want a clock to see the time, so to calculate the delta in time. So in a Reanimated 1, we use a clock. So we use clock, and for every frame we calculate the delta in time and the delta in position. So the first thing I'm gonna do, so in use code, I'm gonna start the clock, because by default it doesn't update. So we start the clock, and we're going to assign the velocity. And for the velocity, we already have functions that calculate the difference between frame, which is so named diff. So we're gonna divide dt by dy by dt, and for dy and dt, so dt is, I'm gonna use diff on clock, and here I use diff instead of diff, because diff is very tricky. In Reanimated, it's buggy because of the proc. Since they added the proc node, diff doesn't work anymore, because it relies on other proc functions. If we use the diff implementation from redash, the problem is that diff is based on the node evaluation, and here, just to be on the safe side, I like to make sure that it's calculated on every frame, so that's why I use diff. I just had so many times where using diff was not yielding the expected result because of the evaluation order and the evaluation, that I just now, out of safety, use diff directly. But of course, you could also calculate it manually like we did in the Reanimated 2 example. But that should look like what we came up with. So dy of y. And so these guys we get from Redash. And again, here, if we want to try if this works, we need to calculate skew-y and interpolate it from the velocity. So input range, I think we had 0, -5, -5, or -7.5 we can put maybe. Or I think maybe 10 was good. I don't know. Let's see. So, and output range. So math pi divided by 9. 0 math pi divided by 9. So interpolate from Reanimated, which we have it here. We can use it into a transform. Skew-y. This becomes an animated view. I think here I must have, because of I use the same folder here, I think it's using the Reanimated 2 types. That's why. So you see here it animates nicely. Here I think I just need to run a yarn install for this error to disappear. It's just because it's based, it thinks. So you see this is a Reanimated 2 types, not the Reanimated one. But pretty cool. I think it works nicely. So the jelly scroll effect brought to us by the Cuberto agency. Guys, I hope you enjoyed this example. I certainly enjoyed taking the scroll handler from Reanimated 2 for some tests, and it was also quite fun to calculate the velocity manually. In the next video where we're gonna use Reanimated 2, we're also gonna play with physics-based variables, and we're gonna take it one step further. So I am really looking forward to talk to you soon. This week, we are continuing to build the React Native Fashion app. And in the meantime, happy hacking.